All right, we just finished part 3 a moment ago, so let's go ahead and let's do part 4. And I want to determine if we can differentiate the function at x equals 0. So here's what we need to know. Here's what you need to know. F of x equals the cube root of x, which is also x to the 1/3. You learn that in algebra and even in pre-calculus. So f of c is f of 0, because c in this case is 0, is going to be 0. Because it's 0 to the 1/3, which is 0. I know I'm writing more than I should, but I want you to be able to look at it when you're home and be able to see what it is. Okay, so the limit, so f prime, and I'm going to switch colors. So f prime of x equals, in this case, f of x minus f of 0 all over x minus 0. So it equals x to the 1/3 minus 0 over x minus 0, which in this case is x to the 1/3 all over x. Now that's x to the first. Now, if you remember from algebra and even pre-calculus, you'll remember that you take, to simplify that, you take x, you take 1/3 minus 1, which is x 1/3 minus 3/3, which is x to the negative 2/3. Or you can say 1 over x to the 2/3. I don't care what method you use, but you can use that as well. Now, one more thing I'm going to talk about real quick is just I'm just going to kind of emphasize with you, differentiability implies continuity. So here's what you need to know, and then we'll be done. F is differentiable at x equals c, then that means that f is continuous. That means if you can differentiate it at a particular point on the curve, then that means it is continuous at that point. All right, so that is section 2.1. Go ahead and get to work on the assignment. It should be WebAssign 2.1. If there's technical difficulties, which I will talk about in class, then you will do the book, and I will post the book assignment on Canvas. But in the meantime, remember, on your group activity, use the limit process. Show all the work, be able to talk about it in the video, and be able to demonstrate how it works. I don't care how you and your partner split it up. You guys make it work, and then at the end, fill out the Google form. So, good luck.